Hello and welcome to Angles and Acid, where we learn things maths and science. In today's video, we're going to look at square numbers, sometimes called a perfect square number, or perfect square. And we're also looking at square roots, which is basically the opposite case. So a square number is basically, if you look at all the numbers that exist, some of the numbers that exist, you could rearrange their little sort of, if you imagine them as dots, you could arrange them to make physically make them a square. So I could have a square that is, 4 dots, that gives me a square. I can literally make a square where the dimensions of that square is 2 and 2, so 2 across and 2 high. So the number 4 is a square number. The next biggest square that I could make, well, it will be basically 1, 2, 3, 3 and 3, so 3 across and 3 in height. That's another square number. If I count all those dots up, basically 9. 9 is a square number or a perfect square. I could go down this line here, and I could make a square with just a width and height of 1. So 1 is also a square number. So what's this business of square roots? Well, a square root is often represented like with this sign here. This is a square root sign. And a square root sign is basically saying, okay, whatever number you put in here, so I'm just going to put a question mark for now, whatever number's in there, can you tell me if it was arranged into a square, if you sort of mentally figure that out, what would be the length of one of those sort of sides of that square? Okay, so if I had, what is the square root of 9? It's basically asking what would be the width of that square. Well, we already know from up here that the square has for the number 9, its width is 3. So that answer is 3. So what's going on there? Well, basically, we can say that 9 can be expressed as a square. Not very helpful. But basically, this whole representation can be represented as 3 to the power of itself. So 3 to the power of 2. And that's why I mentioned in the previous video about powers, is that I refer to them as, squares or cubes and so on. So we got 3 to the power, 3 times itself gives me 3 squared. Same thing over here. 4 can be expressed as 2 squared. 1 can also be expressed as 1 squared, but obviously 1 times 1 is just 1. So what I've really written here is square root of 9 is really square root of 3 squared. And it turns out the square root and a square, they cancel, okay? So you can imagine that with my little pen here, that as soon as I put this square root sign, this cancels out this square, and all that's left behind is the number 3. So that's basically square roots. I probably haven't done a great job explaining it, but hopefully this communicates the idea. I'm going to do some examples, but there are some rules that can be really helpful when you're trying to find the square roots. I find that square numbers, not so helpful. Square roots, much more helpful. I find them occurring a lot more of the time when I'm doing basic maths or rearranging equations or simplifying things like that. Square roots usually come in handy. So here are some rules. So basically the one I just did now is, if I have a square number inside of a square root sign, they basically cancel out. And that's the same thing as having that whole square root problem itself. Put brackets around and square it. Again, that still cancels it out. That's what the first sort of line of that rule is showing. The next one there is that if inside the square root, it's actually the product of two different numbers, then you can actually splice it and then sort of separate those two. So square root of a times b, bracketed, is equivalent to square root of a all by itself times by square root of b all by itself. And similarly, you can do that with division. So if I've got square root of a over b, that could be the same thing as square root of a all divided by square root of b. So this is just ways of rearranging things, and sometimes that can really help you solve a question, solve a problem, simplify. So this is pretty advanced for my year 7s, but it can't hurt to know them already. So let's go look at some examples. So I've got some questions here. So first one's pretty easy. Square root of 25. Well, I can rewrite 25. 25 is actually a square number. 25 is basically 5 times itself squared. So it's 5 squared. And we know that square root and a square cancel out, so my answer is just going to be 5. Let's do the next one. This one's a little bit harder. Square root of 18. 18 is not a square number, but maybe I can do a little bit of working here and use the second rule that I just showed you earlier. So can I imagine 18 as a product of two different numbers, and one of them hopefully being a square number? Well, I can imagine 18 is the same thing as 2 times 9. Okay, well, according to the rules that I just looked at earlier, well, that will be the same thing as 2 times 3 squared, because 9 is a square number, so that's the same thing as 3 squared. And also from that rule, I can split it apart because there's a times symbol between them. So let's break that up. So that's going to be equivalent to square root of 2 all times by 3. So the answer is basically 3 outside of square root of 2. And that's as far as we can go. Square root of 2, that's pretty, that's as far as we can really go, because we basically reduce it down to a prime number. Let's look at this one here that I've also got here. Square root of 4 over 9. Well, we can use that rule that was just on the previous slide. I can split it up. So let's do square root of 4 all divided by square root of 9. Let's see what we can work with there. I'm just going to rearrange this a little bit. That bit is equal to square root of 4 all divided by square root of 9. Turns out that I've chosen the question to work with me here. So square root of 4, well, 4 is a square number, 2 and 2. So that's going to be square root of 2 squared. And 9 is the same thing as 3 squared, and we know that squares and square roots cancel each other out, and our answer is basically 2 over 3, or 2/3 is our final answer. So I hope this video helps you with what square numbers are and what square roots are, and some of the tricks you can use to try and work your way through a problem and reduce it down to something a bit simpler. The next video, Again, I can't remember. I should probably write it down. But again, I'll leave you a link right here so you can click on the next video. I'll catch you in the next one. Thanks, guys. Bye.